All right, guys, let's take a look at some of these problems that you tried yesterday. You are going to need a blank piece of white paper that you will very neatly organize and label with the number of the problem we're looking at. Even if you've solved some of these, I'd like you to solve them again along with me so that we can reinforce some of the things that keep coming up in a lot of these bar model problems, so we can add those to our understanding of how bar models work in general. That will better prepare you when we get into chapters 2 and 3. So I'm going to solve these. You do them right along with me. And then at the end, we're going to send you off to work with some partners to try and model out some problems that you have seen before, separate from these, okay? So I am going to go through 1, 2, 3, 4, 5, 6, 7 different problems. You can pause, rewind, fast forward, go anywhere you need to go to understand these problems, but make sure that you are able to communicate not only how you would model, but also how you would solve all 7 of these problems. I have switched around the order a little bit because I noticed that some seem to be a little more challenging than others. So if you're thinking that some of them look like they're in the wrong spot, you are correct. So let's take a look at this one first. Pedro has some model motorcycles and some model cars. So it looks like my variables are going to be motorcycles and cars. He has 132 fewer model cars than motorcycles. So he has fewer cars than motorcycles. So my bar for cars will be smaller than the one for motorcycles. And since he has 132 fewer cars, that must mean that he has 132 more motorcycles, like we talked about in class. Pedro has 352 motorcycles altogether, which would go here. And we're trying to figure out how many cars and motorcycles he has altogether. So we would set this up exactly as we see here. We would notice these 2 parts are equal. We'll, of course, dot those. And we want to figure out how many there are altogether. And we already know that there are this many motorcycles, but we need to figure out how many cars there are so that we can then add that sum together to get our question mark. So I know that this spot right here is the same size as this spot right here. Since those were marked as equal parts, then I can just use this top motorcycle bar here to subtract and figure out what this piece is. 352 minus 132 is 220. And once we get 220, we know that this is 220. And so 352 was my total motorcycles and 220 was my total cars. And when you add those together, you get 572 motorcycles and cars all together. So again, if you need to rewatch that one, feel free, or you can move on to the next one. Number 5 is very, very similar to number 4. So I'm just going to tell you that the answer to this one is 3,521 people. All right, let's check out number 6. Number 6 says, Durai buys a dining table and 8 identical chairs for this cost. So he has a table, which costs a certain amount, and then he has some chairs, and there's 8 of them, and they're identical. So I'm going to draw 8 equal parts. Notice that my table is a different size. It doesn't have a dot in it. I don't know how big that is. But what I do know is that when he buys the 2 of them together, they cost $294. Now I'm told that the table costs $198. I need to figure out the cost of each chair. So I'm looking for this. So in order to figure out how much one chair is, I need to figure out how much all of the chairs are. Since the entire whole is $294, I can subtract off $198, and that will leave me with how much the chairs cost all together. So I'm going to take 294, and I'm going to take off 198. 294 minus 198 is 96. So that means that the chairs altogether cost $96. Now, there are 8 of them, and they are all equal. So this is what we talked about when we did that 4 square the other day, and we were talking about what models show. I'm looking for a part, so I'm either subtracting or dividing. In this case, there are equal parts everywhere, which suggests division. So I have 96 surrounding 8 equal parts, which means that I can take 96 and divide it into 8 equal parts to find out what one part is. 96 divided by 8 is 12, so that means that one chair is $12, because 12 times 8 is 96. And then when I add 96 to 198, I get my original value of $294. So $12 for one chair. Let's check out number 7. Mr. Suresh is 6 times as old as his daughter is now. After 14 years, their total age will be 63. How old is Mr. Suresh now? This situation is something we will come across a lot in bar modeling, and it is called a before and an after. I can recognize that this is a before and an after situation because the text intentionally tells me something is happening right now, and that after something has passed, things are changing. So that's a before and an after. So the way we set those up is we write a B and an N for before and after. And we draw ourselves a little T-chart. So Mr. Suresh is 6 times as old as his daughter is now. So we have Mr. Suresh and his daughter. And right now, he is 6 times as old as she is. Which I set up like this, because that shows 6 times greater the amount that she is. And I know we don't know how much those are, but it doesn't matter as long as our parts are equal. Now, 14 years goes by. And now their total age is 63. So I don't know what their bars look like yet. The only thing I do know for sure is that his bar is larger than hers, but all together, whenever I would draw them, their total age needs to add up to 63. So I need to figure out how old Mr. Suresh is now. Well, the key piece of information here is that 14 years have gone by. So technically, he could still be those 6 times older, except the thing that's changed is that now we've added on to whatever that is 14 years. And then the daughter has also aged 14 years. So I'm going to put 2 dots in these because those are equal to each other, different than the 1 dots, which are equal to 1 dots. So now I'm thinking, okay, geez, this is really annoying. I sure wish that I had a situation like this. It's so nice, like in that last problem, when you have something easy like this, like 5 parts and the whole thing's 20, and you can just do a simple 20 divided by 5 and get 4. I love situations like this. It's so nice. But this one's annoying because these 14s are in my way, and I don't only have equal parts. So the way you can get rid of an annoying situation like that is to just cut them off. This whole right now is 63. But if I chop this 14 off, it will be 14 less than 63. If I also chop this 14 off, it will be another 14 less. So I'm going to take 63 and I'm going to subtract 28 because 14 and 14 is 28. And I'm going to see what my new whole is. If I do that, 63 minus 28 is equal to 35. So that means that all of these equal parts, 1, 2, 3, 4, 5, 6, there are 7 equal parts. Those 7 equal parts are equal to 35 because I chopped off those other ones. So I have 35 surrounding 7 equal parts, which is very similar to this situation. It's just that they're spread around. And so I can take 35 and I can divide it by 7, and I know that math fact that that's 5. Which means that each one of these little green guys is 5. Now, not too fast because it feels like you solved it and you're done, but there's a little bit more. I need to figure out how old Mr. Suresh is right now. Right now, he is 1, 2, 3, 4, 5, 6, 6 equal boxes that are 5. So all of these are 5, which means that all of this is 30. But then he also has those extra 14 years because this is how old he is now. So 30 plus 14, he is 44 years old right now. That one's a little tricky. If you need to rewatch it, please do. All right, let's check out number 8. There are 765 marbles in a box. There are twice as many blue as green. There are 3 times as many red as blue. And we're trying to find how many red there are. So when I first read this, the first thing I think to myself is that there are more than 2 variables. This is the first time we've had more than 2 variables in our class. So I'm going to take this one step at a time. There are blue marbles, there are red marbles, and there are green marbles. So I have all of those variables. Now, I do know altogether, because I'm reading my text in order here, there's 765 marbles in a box. Okay. Now, there's twice as many blue as green. So there are twice as many blue as green. Okay. There are 3 times as many red as blue. So red has to be 3 times as big as blue. If blue is 2 parts and red has to be 3 times as big as that, that means red will have 6 boxes. Because here's 1 time as big, 2 times as big, 3 times as big. 6 boxes, 3 times as big as blue. Now, how many red marbles are there in the box? I'm trying to find how much this is. So first I need to figure out how many is just one box. Well, I have 765 surrounding 1, 2, 3, 4, 5, 6, 7, 8, 9 different parts. 765 surrounding 9 equal parts suggests that I will divide. And 765 divided by 9 is 85. So that means that 1 part is 85 marbles. So then how many red marbles are there? Well, this would be 85, this is 85, this is 85, this is 85. So I would have to do 85 times 6 to figure out how many red marbles there are to solve this thing once and for all. And 85 times 6 is 510 red marbles. I'm not showing you the long division or the multiplication or subtraction on here right now because those are separate skills that we will be addressing soon. If you are somebody who struggles with those things and you're forgetting how to divide or how to use that, you are welcome to use a calculator at this time. And then when we get into division and multiplication, I will take the calculator from you and you will learn to do it in your head. But just for now, while we learn this bar model stuff, I am totally open to using a calculator. All right, let's check out number 9. On Sunday, a florist sells 96 roses. She sells 4 times as many roses as lilies, and she sells 78 more carnations than lilies. We're trying to find how many carnations. So again, there are more than 2 variables. There are roses, lilies, and carnations. Those are 3 different kinds of flowers. So we have roses, lilies, and carnations. So on Sunday, she sells 96 roses. She sells 4 times as many roses as lilies. So careful with this one. She sells 4 times as many roses as lilies, which means she sold more roses. And so now, this is why I say never to write in the bar, because we had to cut that thing up into 4 equal parts because the roses have to end up being 4 times as big as the lilies do. So then she sells 78 more carnations than lilies. So here's carnations. It would be the same as lilies, but it's 78 more. So I'm going to add a bar to represent 78. Now that bar is not necessarily equal to those other ones. It's just a separate piece, so I'm going to add that on. And I need to figure out how many carnations have been sold here. So, I mean, 78 is known. This is 78, but geez, wouldn't it be nice to know what this mystery piece is right here? Well, we have other information up here. We know that 96 is surrounding 4 equal parts. So I could divide 96 by 4 to figure out what one of those equal parts is. 96 divided by 4 is 24. So if one part is 24, that means this is also 24 because it's an equal part. Then we can simply add 78 and 24 and find that there are 102 carnations that have been sold. That one's a good one. I really like that problem. All right, now I'm going to show you 2 hard ones. At this point, if you could do all those problems we just did and you feel good about it, you are in great shape. These next 2, if you can do them, you're in excellent shape. But if you're struggling to do them, you're going to be okay. It's not the end of the world. Let's take a look. Tammy had 73 stickers. Cherie had 17. Tammy gives some to Cherie. And now Tammy has twice as many stickers as Cherie. How many stickers did Tammy give to Cherie? So this is 100% a before and an after problem because something changed and there was something before and something after. So I have the variables of Tammy and Cherie on both sides. Tammy had 73 stickers to start, so I'm going to go ahead and mark that. And Cherie had 17 to start, so she's much smaller here. Cherie had 17. Now Tammy is going to give some. So Tammy's going to lose out. So she's going to end up having less than 73. And that amount that she loses will be the same amount that Cherie gains because she's passing them off. And I'm told, so I'm just going to make a little mark because Tammy's giving some to Cherie. I'm going to just do this little mark to remind myself. So now Tammy has twice as many as Cherie in the end here. So she ends up with twice as many. How many stickers did she give her to make this happen? So basically we need to chop an amount off of 73 that when I add it to 17, it ends up being that Tammy is twice as much as Cherie. So here's the thing, when these before and afters happen, your gut is going to be to start guessing and checking, but you don't need to guess and check. There are ways to model through this so that you don't have to spend your time doing that. There are a couple of pieces of information that we can figure out here that might help us. One piece of information that could be relevant is how many more stickers in the beginning Tammy has than Cherie. That could be helpful sometimes. Another piece of information that's helpful sometimes is how many there are altogether. Because really, this amount over here, this hole, should match the hole on the before side. Because there's no stickers that came in from somewhere else. The stickers came from Tammy, so all they did was get moved. They just got moved around. So altogether, 73 plus 17 is 90. So they had 90 stickers altogether from the beginning, which means they still have 90 stickers here. It's just that some of them were given to the other girl. There wasn't like a friend who came in and added stickers or something. So now this is a problem we know how to solve. We know that we have 90 surrounding 3 equal parts, and so we can simply divide 90 by 3, and 90 divided by 3 is 30, which means that one part is 30. And so how many stickers did Tammy give to Cherie? Well, Cherie had 17, now she has 30, so the difference is how many were given to her. 30 minus 17 is 13. So that means that Tammy gave her 13 stickers. I encourage you to try that one again on your own without watching me do it and see how you do. All right, last one. Let's try number 11. Lily and Mary had 48 beads in all. Lily gives 15 to Mary, Now they have the same. How many did each girl have at first? This one is also a before and after problem. Something's changed. If you want to, pause the video right now, since you have some background in before and after from that last guy, and see if you can solve this by yourself. And then play it and see if it matches up. Okay, so let's see. Lily and Mary had 48 beads in all. So their whole is 48. Okay. Now Lily's going to give 15 to Mary. So even though Lily gave 15 to Mary, their whole didn't change. Because they just passed them between each other. But 15 have been given to her. And now they have the same number. So in the end, they have to end up having the same amount. And in that same amount, somewhere, there's the 15. Well, I'm going to actually redraw this a little bit because I want to show that 15. So here's Lily and here's Mary. 15 were given to Mary from Lily at some point. So you know there's 15 in here somewhere. This is 15. And now they have the same amount. So there's no equal parts at all. I just know that there's 15 plus some amount, and that this is the same as 15 plus that amount to get 48. So how many beads do they each have at first? Well, since there were 48, and they need to have the same amount, I could ask myself how many. Well, if they have to have the same amount, 48 divided by 2, so they have to have the same, is 24. So this whole needs to be 24, and this whole needs to be 24. But she gained that 15, which means she only started with what's right here. So we can find that by subtracting. 24 minus 15 is 9. So that means that she only had 9 at first. So Mary had 9 beads at first, and then Lily has 24 here, but remember she gave 15 away, which means before she had 15 more. So if I add these up, that means that Lily started with 39 beads. And then you can double check to be sure. 39 plus 9 is 48, and if 15 was taken from 39 and added to 9, you would get 24. So everything checks out. And we know that each girl at first, that Lily had 39 and that Mary had 9 beads at first. So as you can see, these bar models really just help you. They're just a thinking tool. You have to do all the thinking. The model will not solve it for you. You have to think about where things go and what makes sense. You're totally capable, so keep persevering and go grab your bar model quiz from the teacher and try to model some of those that are on there.